Let's keep on building the DevTips logo animation using physics. So we'll have a hardware accelerated CSS animation as you suggested, but it will also be physically accurate. Slightly over-engineering the animation, but it's fun. You're watching DevTips, and I'm David. This episode is sponsored by FramerX. FramerX says that they have the easiest and most advanced design tool. And I sort of have to agree. As a developer, it's very easy to get in there and you get things up and running and it looks beautiful. But everything is React and you can build your own components. So you can actually build things in FramerX. And if you build a nice component, you can then export it to their Framer store. And what's pretty neat is that because you're already thinking in components, both as a designer and a developer, everything is built like components in FramerX. And it is React, so it's components the way a developer would think of a component, and it's a component the way a designer would think of a component. It's truly awesome. You should really check it out. Check it out in the link in the episode description. Thank you. Bye. So if you remembered, we did this episode where we tried to animate the DevTips logo. It was really hard. We did everything very much incorrect. Can I stop this sound? We did a lot of mistakes here. But we learned a lot, and especially from comments here. What many people suggested is please use the built-in transforms because they are hardware accelerated. Here's a code pen. Someone made something. Okay, even though this is an image, everything works way better because they are using scale. So if we run this again, it's smooth. So everything here are keyframes that transforms scale. We can do that, but to simply change it, it would be too easy. So I did it here with scale and just, yeah, it's smooth. Okay, I get it, it's smooth. Blah, blah, blah. Boring. If everything were to just do transforms, this episode would be over. And that would be boring. So, let's over-engineer this. If you remember in the episode, I wanted, from the camera, the DevTips logo to come here, dunk, and land on my forehead. So I tried doing that with like different Bezier curves. And I ended up with this. Okay, so it's going in the wrong way, but never mind. And it doesn't really look... It was difficult to get it to like bounce. So I figured let's do it with some physics simulation. So I built my own small Observable notebook. If you haven't checked out Observable, you should totally check it out. It's great for sketching out different concepts, and if you're doing data processing and stuff, it's pretty neat. So I made a notebook here, simulating bouncing ball to generate realistic physics CSS keyframes. And I was heavily inspired by this article, Modeling in Physics, and basically I just stole this code. You have a ball. You give it a position, you give it a velocity, and then you have a mass to have gravity act on it. So here is gravity. And you have a radius to have like the friction of the wind, like counter it. On the ball, you have restitution, which is basically the bounciness of the ball. So if it should just drop like a brick or if it should bounce a bit. By using some just standard force physics, we can get the ball to drop. But I also was very much inspired by this package, create-keyframe-animation. So, what is this? Basically, it's, you know that we did this, keyframes move from 0% to 100%, and then we transform, that's what we're supposed to do. What this package does is basically that you can enter an array of keyframes or positions and opacities and scales, and it will just generate the CSS for that. We can give the animation array objects that have the properties. So this is the X, Y, and then the opacity and the scale. I made this ball to drop. Whoop, it's dropped. So this looks physically accurate. Boom, 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 boom. And what I've done here is I've specified a ball with some stuff here. Like it has a mass, a radius, and restitution, the bounciness. And never mind this stuff. And then it goes into a loop, which is basically an animation loop that Observable uses. And we have some forces here. And it calculates what is the position X and the position Y, depending on the velocity, which is derived from the gravity, which is derived from the forces against it and the mass and all that stuff. And then we draw it on the canvas to update the position in X, the position in Y. We draw the radius because we're doing an arc, so we're drawing a circle. And it has a circumference, blah, blah, blah. And then we fill it to make it a black ball, like that. And then we yield the canvas. So in Observable, this while loop runs 60 times per second, so it's an FPS of 60. So that's what I've included here, a frame rate. You can go check this out. It's just some basic physics. And if you don't understand it, don't bother. It's just making it physically accurate. But then I have this step. Add each animation step to the keyframes array if it's still moving. So basically, while the ball is dropping and something is happening, I'm taking each position and adding it to a keyframes array. And then when it's lying down, the loop is still going on, and then I just want this check to not add any other keyframes when it's not moving. So I have a keyframes array, and to that I push these things that I'm using for the create animation package. So I'm pushing a translate of a X position and a Y position. And basically it's only the Y that is changing, the X is constant. And then the canvas is yielded, so the image is updated here. So it's drawing, the ball is dropping, boom, 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 and then it stops. And once it stops pushing to this array. So the keyframes array initially is empty, but then after we run this simulation, it has the first frame is this array, translate. So it's 200 x, but then it starts almost at the top, 0.272. And in the next loop, in the next iteration, the physics has said that it should move slightly, half a pixel lower. And for the next frame, it's moved 1.5 pixels. So it from here to here, it moved 0.6 pixels. But from here to here, it moved almost 1 pixel. And that is just because gravity and the acceleration, it goes faster. And then somewhere down here, let's check. No, it's still, it's incrementing. No, here, check this out. So here it's incrementing all the way down to 185. So the radius is 15 and the height of the canvas is 200. So it drops to the bottom. So it goes from 168, 178, 185. That's the bottom. And then it goes back up 181, 178, 175. So that is the bounce we get here. And that is the whole effect I want. I want it to bounce. So a small recap. What did we do? I've written using other people's wiseness to simulate a ball that is dropping and bouncing. And what I do is that I use the values from this simulation to populate this keyframes array, which has all the translation here. And then I have this code. So it takes to the animations object, which is the thing in this library. We create an animation that we call move. And to it, we add the keyframes array, which is all this array. Then we add some presets here just to control it. And then later on, we have a selector to find the circle ID. And we add the animations to that one. We bind the move animation we just created above here, the move animation. We tie that to the circle. And what is the circle? The circle is basically here, I'm just rendering HTML, which is an SVG that has a circle in it, that has an ID called circle. And then it has a radius that is 15, like in the animation, like in the simulation. We fill it with blue. Let's reload this and do this again and just figure out what is happening here. We run the simulation, you see the ball dropping. For each frame in the while loop, we push to the keyframes array. So we populate this array with translate to X and Y coordinates. We register this animation keyframe and then we run it. So we register it on this circle with an ID. We register this animation called move. It moves and stops there. And if we inspect that, we see that this item has an animation move. Isn't that amazing? And what does that look like? So if we search for translate, we see here that we have 0%. It has automatically built 0%, 125, 25, 375, and it translates with the pixels. So this is very, 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 very basic. We have an accurate simulation. It looks physically accurate for what we want to do. But this is not what we wanted to do. Now the animation is the dev tips lower, duk, 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 duk. It drops like this, duk, duk, duk. And I guess that's fine, but that's not what I wanted. I wanted to drop duk, 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 like that. So how do I do that? Remember here, we generated these keyframes that has the translate. We want to use scale here. So we want to scale it to be really, really big at the first keyframe. Smaller, 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 smaller. It bounces, gets bigger, and then it gets smaller again, bigger, smaller. So in this small code, here, instead of translating like this, we would like to scale. So each keyframe should be a scale. Of course, we have the position Y of the ball. It goes up and down. So we want to use that somehow. But we want to use that in relation to its size, its radius. We also have a viewport here. So it's 200 pixels high here. So we want to take advantage of that. We know that it's 200 pixels high. So we want to use that. We want to use the height, which is a variable I'm using here. And everything is done in relation to this height variable. But we want it to change. So when the Y, in the beginning, the Y is really, really small. It's just a few pixels. If we take the radius of the ball and divide by a really, really small number, the radius becomes really, really big. But we still would like to constrain it somehow. In the end, we want it to have the same size as it has right now. So when it's dropped, we want it to keep this radius 15. So how do we do this? That we know that the last, let's go to the last item here. It stopped at y equals 185. So by using that, we know that if we take the height, that is 200, minus the ball's radius, height is 200, the ball radius is 15, this becomes 185 divided by the position that in the final step is 185. So I have 185 divided by 185. And what is that? 185 divided by 185? 1. Which is what we want. We want it to have the final scale in the end. So by doing this, we should, I hope, we should get it to, from initially the height is 200, the ball radius is still, this still amounts to 185, but from the first position we get 185 divided by what was the first array position, 0.27, which means that we in the first instance will scale this to 685 times its size, which is big, which is this big, which is what we want. So let's try this. That ball should look the same. It's still running the simulation. We're not doing anything else but populating this array. And now we're populating it with scales here. So it starts at 678 times, then goes to 226 times, then 113 times. Drops down to its size, and then it goes a bit larger, and then finally going back down to, yeah, it bounces quite a few times. It's much more easy to see that. So let's see, what does this look? Register, run it. Boom. We didn't see it that well because it's centered at 0, 0, because we did not translate here. So let's just modify this so we translate it. I'm back. Get really frustrated with this. After drawing stuff and then thinking, I just realized, what am I doing? Why am I trying to move it? Scale like that, and everything will be fine if we just ensure that the SVG transforms. So we move the circle. We have the center X of the circle as 0, the center Y as 0. And then we make a transform because it's just matrices. So what this does is basically just moving this circle to the center of the SVG. So now we don't have to care about the translation. And I think someone suggested this in the comments before for our initial problem. So I got stuck in the same thing. So what happens now if we just refresh all this? We have the animation, it works, it drops, we get an array, it only has the scales, which is fine. And then we register them, and then we run it, boom, 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 boom. Boom, boom, boom. And now we can sort of modify this, so if we want, I don't know, a different mass or something like that. Let's just say, I don't remember which direction. Let's move it like that. More bounce. Tuk, 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 tuk. Got several more frames. Register them, run it. Boom, 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 boom. I like the old one. Let's just move it back. I almost want it to bounce less. Perhaps have more mass. Dunk, dunk. What happens if I increase the mass? Not much. More. Doesn't happen much. Okay, let's just keep it there, like that. We got some new ones. Register, we run it. Oh, I like it. How do we do this now? Let's take this code, the generated keyframes, and just move them to our code. Here we go. Can I go here? Here's the styles. We have all the keyframes here. Let's just edit as HTML. Copy all this. So let's just remove old stuff. Oh yeah, this will go to shit, probably. We're not doing that animation any longer. We're adding a style here. So we have everything there in the animation move, and then let's just see. Move. How did that look? I don't even know what that means, but hey, why not? Let's try it. See what happens. Ha! Pretty neat, but it's not centered. We need to center it. Do I even need this? Do I need this? Do I need that? So if I do this smaller, what happens then? 200, 200. Does something happen? It got larger. What happens now? So I'm just lucky that this is the size of my window. Div class wrapper. Transform scale 0.5. I make it half the size. Will this work? Yes! I'm cheating. Never mind. I don't care. Boom! There we go! And it's bouncing. Imagine this with sound effects. And a swoosh. Oh! Okay, we got it working. Thank you for watching. Please write comments and suggestions what you thought about this episode. If you know a better way to improve this, I'm sure there is. I maybe will do that. Not sure. If you haven't checked out FramerX, you should totally go and check it out. There's a link in the episode description. It's pretty awesome. I honestly, to God, like that. These episodes come out every Friday at GMT 0800. So you should just figure out your own time zone. Thank you for watching. This is Dev Tips. I'm David. See you in the next episode. Ciao!